Outreach is very important to us just because energy is a hot topic right now, especially in the state of Kentucky, and we're very much in the game.
For a laboratory building with as many fume hoods, with 100% makeup air, all the demands for energy, getting LEED Gold is actually very ambitious.
We can make some adjustments to the system so that we can continually reduce that energy usage for the building, not just for today, but for the life of the building.
As I think about this building, it is sort of a living machine. It has the ability to adapt, to learn, to grow.
From chemicals that capture carbon dioxide and flue gas, to algae that convert CO2 to fuel, to a new kind of concrete that could save lives. CAER is leading energy research in Kentucky. The new 43,000 square foot laboratory building will significantly expand the center's research capacity in 3 areas: batteries, biofuels, and solar and electronic systems. With $11.8 million in federal stimulus dollars and additional funds from the state and UK, the building sets the standard in energy efficiency. An additional $3.5 million in state stimulus funds allowed the project to seek LEED Gold certification.
The budget times are tight. We outgrew our existing facility. We needed the space. However, with that comes bills, and so it was very important to make sure that we could build this facility and use it to our best of our abilities, but also still be able to pay for it and keep the lights on. Going forward with an energy efficiency attitude and making sure that we design this to the best that we could when that's implementing all of the energy savings features, whether it be architectural or mechanical, was very important to us.
Kevin, our engineer, his firm, CMTA, is one of the leaders around the nation in some of the technologies that we put into this building.
It really takes everybody being a part of it. It takes architects, engineers, users of the facility, everybody to make these good decisions without sacrificing the importance of what the building really needs to do, which is promote research.
Our intention from day one was always to get to LEED Gold. That did push us because a laboratory building, especially research, is a huge consumer of energy. From the very beginning, we had to treat this as something different and a little bit unique.
To achieve all of the potential points that are available in the energy and atmosphere credit, we would need to reduce the energy in the building by 49%. We were able to even exceed that level and actually save 54%.
We've certainly implemented some new things for the university. We wanted to see how certain processes and items function, and hopefully we can implement those in new buildings or existing retrofitted buildings on campus to help improve our energy efficiency.
Probably the most significant thing that we've done is worked with environmental health and safety to be able to demonstrate technologies such as energy recovery wheels.
Energy recovery wheels have been used a lot in a lot of buildings, but they've been shied away from in laboratory buildings. We wanted to challenge that paradigm.
Out of a laboratory, you have to have 100% makeup air, meaning the air goes straight out, new air comes in, not recycled. So what we've done is put in those lines a big wheel that recovers the heat and the moisture out of the air going out of the building and transfers it into the air coming in.
So when it's hot and humid, which it is a lot of times in Kentucky, we're able to reduce that moisture and that heat that you feel from that humidity.
But in order to do that in a laboratory, you have to be worried about cross-contamination. And so we have air quality testing in every laboratory. It's tested every 15 seconds.
And they're monitoring all of the different particulates and TVOCs that are occurring in the laboratories. And if any of those sensors then see a spike, all of that air gets flushed out real quickly and protects the researchers.
CAER is also saving money for heating and cooling water with 154 geothermal wells under the parking lot. By using the Earth's constant temperature, geothermal is 6 times more efficient than traditional systems.
Geothermal works very well in Kentucky. We actually are probably much more familiar with it than other parts of the country.
It's a technology that has been proven to be very energy efficient. Instead of using boilers and chillers, we're using actually the ground to absorb the heat.
We also have process water loops within the building that are tied into the geothermal system for cooling equipment.
A lot of the experiments require cooling water, and most of the time that water just comes across the equipment, cools it off, and then goes to a drain. Well, our engineers figured out a way to recycle that cooling water and continually loop it through the building so we're not wasting gallons and gallons and gallons of water every day for the life of this building. Also, to help us kind of reach those energy usage goals, we had to make the building envelope very energy efficient. In most places, we doubled up the amount of insulation that's in the walls as well as the roof. We put a white coating of roof on top of the building that reflects the heat, the sunlight, There is a insulated glass called a nanogel. That 1-inch piece of glass provides the same insulating value as a brick wall. So even though we're getting light through that, we're not losing our energy efficiency.
The scientists, lab technicians, and graduate students who will benefit from these energy-efficient technologies work in 3 areas. This building provides the Kentucky Argonne Battery Manufacturing Research and Development Center with specialized facilities to produce and test the next generation of batteries.
One of the great things that we were able to do by getting these awards is that we're able to leverage funds the state wanted to put into the Kentucky Argonne Battery Center. And so we were able to put in brand new, much larger, unique spaces for battery manufacturing, prototype lines, for testing, and for materials development related to energy storage. There are 2 clean rooms in which you can do the roll coating to make the cells. From there, they can be taken into a dry lab.
2,000 square foot dry lab, one of the largest in this region, if not in the United States. When it's 70 degrees, it needs to have 0.5% relative humidity, which is a very, very dry space.
That's very important because then the next part of the project is put lithium, which will react violently with water in the air, onto these. And this allows us to really operate like a manufacturing plant would. We also have then test facilities. These include fireproofed cells that are away from the building that we can use for doing initial cyclings. If there's going to be a catastrophic failure, that's when it'll occur. They can all be monitored from inside this building, greatly reducing any risks to the people doing the work.
The Biofuels Laboratory, funded by the congressionally directed Kentucky Biofuels Program, tests fuel quality and develops new processes and products.
It's an open access facility. Any of the researchers in Kentucky in biofuels can get access to the equipment and to the personnel in the facility to help them with their work. The same for industry within the state. Our work here is primarily in conversion technologies and fuel testing. But this is a great step forward for the program in that this laboratory was designed specific for this sort of work. So it has the appropriate hoods, has large walk-in hoods for reactor systems, and then has a significant portion of the laboratory set up specifically for analytical testing.
In this new lab space, UK chemistry professor John Anthony's team is developing materials and making devices like low-cost organic solar cells that convert sunlight into electricity.
It incorporates a dedicated test area that allows you to test under controlled environmental conditions, as well as a specialized dark room for testing performance. So there's 4 stations, each a separate dark room that we can set up to simulate sunlight and then test cells both in light and dark for their behavior. Finally, there's access to the roof, and there's an area on the roof that's set up to hold cells or arrays of cells outside and do real weathering tests and performance testing.
State stimulus funds allowed CAER to share the unique energy technologies inside this building with visitors.
Outreach is very important to us just because energy is a hot topic right now, especially in the state of Kentucky, and we're very much in the game. This gives us the opportunity to really showcase the excellent research that we have going on here at the center and educate our students and hopefully try to get them into the STEM careers moving forward. We give a lot of tours in our existing facilities already, not only to school students but to other groups around the state and the country. It's a very open door policy.
So there are a lot of windows from the hallways that can look into the labs. This allows us to take tours through without actually interrupting activities of the lab or worrying about health and safety risks. Outside of every laboratory is a display monitor. We've been able to put in a public education display in the lobby of the building, which is interactive and lets you explore the research of the groups that are going on, as well as looking at all the energy usage for the building. You can compare this building's energy efficiency versus our 1978 laboratory building. It was made to the state of the art that was known then, and so you can see the difference in the technologies that have been implemented in between.
We're going to be able to know if different parts of the building are using more energy than what was anticipated. With that information, then we can make some adjustments to the system so that we can continually reduce that energy usage for the building, not just for today, but for the life of the building.
The building itself is a living machine, one that will test technologies that will impact the University of Kentucky's energy usage for decades to come. And the research happening inside will create the batteries, biofuels, and solar cells to power our future.